Hey guys, we're going to go over this titration calculation, which is in the lecture notes at the end of chapter 17. So I know this is a titration because the question says here that I'm reacting NaOH with an acid. Okay. It also says burette, and we know the only place we've ever used a burette in is when you're titrating things. So that's a pretty good indication of how to approach this. Now the strategy here is very familiar to us because it's just stoichiometry, which of course means dimensional analysis, which means converting things. Okay, so we start reading. A solution of 1.004 molar NaOH is used to titrate an unknown strong acid. 10 milliliters of the acid are there, so let's highlight that because that seems like another important fact. 10 milliliters of acid are used, and the indicator phenolphthalein is added. That's the one we used in class where it was clear at its acid pH and pink when it's basic. The initial reading, okay, so the initial reading of the burette has to do with the base, because the base is what we put in the burette. So the initial reading of the base is 0, and the final is 32. So that means our volume of base, it's going to be final minus initial. So 32.10 milliliters minus 0 milliliters. And of course we know that equals 32.10 of the base. Okay, so I have a volume of base added, and I also have this concentration of base up here. Maybe I need to use those two together. Okay, so then that makes me think the big M, molarity, also means moles per liter. So anytime I'm doing a titration calculation, I like to write it like that because I know that I have a volume in my unit here and I have a volume here. So I could convert this to liters just by going with our conversion factor in the metric system. And so you get 0.0321 liters. I do not drop this 0 because that's significant, right? It comes from our original data and it's after a decimal in integers, so that one's significant. These ones, of course, are not significant. They're just placeholders. Now, I have liters here, so I can take that value and I can multiply to cancel the liters down here. So now we got liters cancel there and there. Okay, so our total number of moles of NaOH is going to be 0.0322. Now my calculator says 0.0322284, but I have 4 significant digits here and 4 here, so I'm going to stick with 4. So 3, 2, 2, and then it's going to round to a 3. Okay, so this question doesn't tell us what the acid is, so we have to assume it's going to be a 1-to-1 reaction, where this is our generic formula for an acid, and it's reacting with the base. And we already know that anytime acid and base react, we're going to make water. So the OH from here reacts with the H plus here. And that just leaves the A and B part kind of hanging out there together. So that's our other product. Okay, so like any stoich problem, when I know the amount of one thing, I can calculate the amount of the other using a mole ratio. So let's clean up, let's go to another page. So we have 0.03223 moles of NaOH that reacted. And our reaction is 1-to-1, so 1 HA for every 1 NaOH. And so this allows me to cancel NaOH and get the number of moles of just HA. Okay. We're not quite done yet because the question is asking us for the concentration of the unknown acid. So the only sort of number we haven't used yet is the one in red here, the milliliters of acid. So 10 milliliters of acid. We know concentration usually means, oh, I can't spell concentration, sorry. Concentration. That phrase usually means one of the units that's on our giant table, like ppm or percent by mass or anything else. We started with molarity of NaOH, so I'm going to guess that when they say concentration, probably the easiest thing to do is to get it in molarity, because that's sort of what we started with for the other compound. Okay, so with that assumption, then we also need to convert from 10 milliliters of acid into, let's see, so molarity means moles per liter. So I got to convert that 10 milliliters into liters. Okay. All right, so then the last step to get the molarity of the acid is to, oh no, I put that in the wrong spot. Here we go. Moles of acid that we figured out before, divided by the liters of acid. And so we get a molarity, when I put this in the calculator, of 3.223 moles per liter of acid. Okay, so that's the answer to the question. All right, so let's take a look at what we did. The first thing we did was we converted the volumes. So step 1, convert volume. Oh goodness. Convert volume to liters. And then in step 2, I used volume of, in this case we know the NaOH, but we could have also known the acid. It could be flip-flopped, where we don't know the base, but we know the acid. So what we could say here is we use the molarity of the known. Sorry, my pen isn't great here for this. And volume to find how many moles of the known. And then we use the molar ratio, which, as we know, comes from a balanced reaction. In this case, our molar ratio was 1:1, but it's not always, so don't assume. And we use that to convert into moles of the unknown. Okay, and so finally the last step is to divide by the liters of the unknown only. You'll notice that we did not ever add volumes up, so we never took the amount of NaOH and added it to the HCl, that's or the acid, whatever it was. So we don't want to do that. You just want to, in the last step, divide by the volume of the unknown. Okay, so this is our summary for how to calculate titration reactions.